This video is presented by Aditi Gurav and Srishti Desai. This video is made under guidance of our mentor, Dr. Dipti Patil. Our topic is Conditional Probability and Bayes Theorem, Application in Data Cleaning and Transformation.
Conditional Probability and Bayes Theorem. How they power data science pipelines. Data cleaning and transformation focus. Challenges in real-world data science. Data is rarely clean with missing values, incorrect entries, noise, and uncertainty as common hurdles. Data cleaning process. Start with messy data including missing values, inconsistent records, and noise. Apply cleaning techniques by detecting errors, filling gaps, and standardizing formats. Achieve clean and reliable datasets ready for analysis. Conditional probability helps analyze the chance of an event given another event has happened, aiding intelligent data interpretation. Bayes' theorem updates probability estimates as new data emerges, handling uncertainty effectively in data science. Data science in action. Visualize data transformation through charts and graphs. Show probability updates driven by new information improving analytics. Implement Bayesian techniques to enhance accuracy and decision-making.
Conditional probability explained. Explore a student dataset showing exam results and study habits for conditional events. Let's write the formula for conditional probability on the board. P of A given B equals P of A and B divided by P of B. Understanding terms in conditional probability. P of A given B, probability of event A given event B, P of A and B, probability of both events A and B occurring. P of B, probability of event B occurring. Notice the highlighted data patterns demonstrating how these probabilities relate in the dataset. Knowing new information like study habits helps us make better predictions about exam success using conditional probability. Conditional probability is essential in data science for analyzing patterns and making informed decisions. Bayes' theorem updating beliefs with data. Understanding Bayes' theorem. Bayes' theorem updates the probability of a hypothesis given new evidence with this formula. P of A given B is the posterior, or updated belief. P of B given A is the likelihood, probability of data given hypothesis. P of A is the prior, the initial belief. P of B is the scaling constant. Prior probability, or P of A, is your initial belief before seeing new evidence. Likelihood, or P of B given A, is how probable the new data is assuming the hypothesis is true. Posterior probability, or P of A given B, is the updated belief after evidence is considered. Bayes' theorem in action. Widely used in machine learning. Powers prediction models. Core concept in AI and analytics. Bayes' theorem updates beliefs with new data, essential for machine learning and classification models. The role of conditional probability Conditional probability and Bayes theorem empower data scientists to clean and transform data effectively for better models. Bayes theorem example about email spam probability. Step 1. Define the events. A equals email is spam. B equals email contains offer. P of A is 0.4. P of B given A is 0.7. P of B given not A is 0.2. Step 2. Calculate P of B. P of B equals P of B given A times P of A plus P of B given not A times P of not A. That is 0.7 times 0.4 plus 0.2 times 0.6 equals 0.40. Step 3. Apply Bayes theorem. P of A given B equals P of B given A times P of A divided by P of B. That is 0.7 times 0.4 divided by 0.4 equals 0.70. This means if an email contains offer, there is a 70% chance it's spam. Final answer: 70% chance the email is spam if it contains the word offer. Data science meaning. Spam filters work. Missing labels are predicted. Data cleaning decisions are made. Science.
Real-world datasets have missing values, errors, and anomalies that harm data quality and results. Probability helps us make smart decisions based on data patterns instead of guessing randomly. 1. Estimating likely values. Probability predicts missing values using related data like salary or job role. 2. Detecting outliers. Probability identifies unusual data points that may be errors by measuring likelihood. 3. Filling missing data. Methods like mean, median, or predictive imputation rely on probability principles. 4. Improving data quality. Clean data creates better patterns and fewer mistakes for improved analytics. Probability is a powerful tool that makes data reliable and trustworthy.
Conditional probability and Bayes theorem. These concepts help visualize data uncertainty, clean datasets, transform data, and support intelligent model building. Key applications of probability. Understand uncertain data. Clean datasets. Transform data. Random decisions. Scientific decisions. Decisions based on guesswork and messy data, leading to inconsistency and unpredictability. Decisions are guided by probability, clean data, and clear analysis, ensuring reliability and accuracy. Thank you for watching this video. I hope this explanation helped you understand how probability concepts are applied in real-world data science.